Salut, we have been given a quartic function and we need to divide it by x squared plus 1. I also want you to notice a few terms are missing in the quartic function. We do not have x to the power 3 and we also do not have the term x. In this lesson, using two different methods, I will teach to find the values of a, b, c, d and e. The first method we will look at is algebraic long division. As you can see, I have inserted the missing terms of 0x cubed and 0x. Notice that I have not changed the question because the coefficients of each variable is 0. This setup helps me to divide the polynomial by x squared plus 1. To begin, I will consider the first term of the quartic expression and divide it with x to the power of 2, which means I now have x to the power of 2. If you're unfamiliar with the process, you can do a calculation on the side, which would be x to the power of 4 divided by x to the power of 2, and using the division law, I can subtract the two powers, hence it will be x to the power of 2. Going forward, I will now multiply x to the power of 2 by x to the power of 2, and that will be x to the power of 4. The next step would be to multiply x squared by positive 1. Placing the variables is very important. Hence, I need to write down plus x squared beneath 3x squared. Moving forward, I will subtract the terms respectively. We have 3x squared minus x squared, and the answer would be 2x squared. You need to notice this will be 0 and this will be 0. The two terms that have not been used yet has to be repeated. Moving forward, I have to divide 2x squared by x squared. Hence, I have plus 2. Identifying and understanding the pattern of moving back and forth would be very important. I will now multiply 2 by x squared plus 1. Take a note of the positions. 2 multiplied by x squared would give me 2x squared, and 2 multiplied by plus 1 would be plus 2. I will now subtract the values respectively. I have 2x squared minus 2x squared, that will be 0. 0x minus 0x would be again 0. And lastly, we have minus 4 minus plus 2. Positive and negative would be negative. Hence, we have minus 4 minus 2, and that will be minus 6. You need to understand that negative 6 cannot be divided by x squared plus 1. Hence, we will represent our answer as required by the question. We have x squared plus 2, that is the answer on top. Then we have minus 6 over x squared plus 1. Remember, we were not able to divide negative 6 by x squared plus 1. Hence, we have to represent our answer as follows. To finalize the answer, I will write the values of the coefficients of a, b, c, d, and e. Starting with the coefficient of x squared, I have a equals to 1. In the answer we have obtained, there is no value for b because there is no x term. Hence, b would be equal to 0. The value of c would be equal to 2. The value of d would also be equal to 0 because as you can see, the numerator in this fraction consists no x term. Lastly, we have e equals to negative 6, and this is your answer. The second method is called comparing and equating the coefficients. For this, I have built an equation by writing the given function of fx on the LHS and the answer required on the RHS. For the first step, consider x squared plus 1 as the LCM. Hence, I will have ax squared multiplied by x squared plus 1. The second term would be bx multiplied by x squared plus 1. The third term would be c multiplied by x squared plus 1. For the last term, since it already has the common denominator, there will be no changes. I have considered the LCM x squared plus 1. I can now proceed to equate the LHS and the new RHS. This is because both fractions have the same denominator, and that is x squared plus 1. For my next step, I will simplify the numerator. I will expand the brackets. I would have ax to the power of 4 plus ax squared plus bx to the power of 3 plus bx plus cx squared plus c plus dx plus e. We will now simplify the like terms by considering the variables of x. Ax to the power of 4 plus bx to the power of 3 would be unchanged as there are no like terms. Moving on to x squared, you can notice we have ax squared as well as cx squared. Hence, I will factorize x squared. Hence, I have a plus c within brackets with x squared outside the bracket as it's common to both the constants a and c. The same scenario would be repeated for x as we have bx plus dx. We can factorize x, hence we have b plus d, and x would be the common variable. Lastly, we have plus c plus e. You can now take a minute and ensure that you have not missed out any terms. We have now completed simplifying the numerator. To proceed, I will consider the given fraction of fx. Since the two denominators are equivalent, I can now equate the coefficients of the numerators. To begin with, I will consider the variable of x to the power of 4. As the name of the method implies, we will now compare the coefficients. On the LHS, the coefficient of x to the power of 4 is 1. On the RHS, we have the coefficient of x to the power of 4 as a. Hence, a equals to 1. When we consider the variable of x to the power of 3, there are no terms on the LHS. Hence, your value would be 0. On the RHS, we have the coefficient as b, hence b equals to 0. Moving on to x to the power of 2, the coefficient of variable x squared on the LHS is positive 3, and on the RHS we have a plus c. The value of a would be equal to 1, hence we have 3 equals to 1 plus c. I can now find the value for c, and that will be c equals to 3 minus 1, that is equal to 2. When considering the variable of x, we have no values on the LHS, and on the RHS we have b plus d. We have found the value of b earlier, that will be 0, which means d also would be equal to 0. Lastly, I consider the constants, which means I have x to the power of 0. On the LHS, we have minus 4, and on the RHS, we have c plus e. We have already found the value of c, which is equal to 2. I have minus 4. I can substitute c equals to 2 plus e. Then the value of e would be equal to minus 4 minus 2, which is equal to minus 6. We have now found the values for a, b, c, d, and e using method 2.